Hello everyone. Please let me know if you can hear me. Hello. Sound check. Okay, so some people say that they can hear me. So this webinar will be recorded and we will share with you the recording afterwards. And I will also put you to mute so that we don't have any extra noise. If you need to say something, you need to write in the message box. And we will wait just 2-3 minutes, maybe someone else will join. So let's stay connected. Okay, looks like no more people joining. So welcome to the webinar, which is called Polarion Managing Functional Safety ISO 26262 in Automotive Projects. We will look at functional safety concept and also how to apply it to the projects which are developing software or electronics, and how this can be implemented inside Polarion. So the agenda for today is to look at some concepts. What is functional safety? How we can perform hazard analysis and risk assessment, so-called HARA. Then to look at Polarion tools, which help to implement ISO 26262. There is a special template inside Polarion, which gives you predefined work items, workflows, data structures. It allows you to follow specific process, and it gives you special reports to see the data in the right way. We will also try to see the demo, live demo of Polarion, and there will be a short questions and answers session afterwards. So what is functional safety? We can look at an example to understand the answer for this question. If there is application that can cause harm, then we can take example airbag exploding when infant is sitting in front seat. Then we need to assess the risk. Infant getting injured, it's not good at all. And then we need to find mitigation strategy or so-called safety function. In this case, we can detect infant in the front seat and disable airbag. And for this, we need to implement special flow of logic in our system. So the car shall have a sensor. The sensor will deliver signal to the software hardware controlling a special device, which is actuator or disabler of the airbag. So this process will be the functional safety process, and the result is an infant in front seat is not exposed to an unacceptable, unreasonable risk. The functional safety standard ISO 26262 was derived, or it is a subset of a wider standard, which is IEC61508. So the 26262 is only for road vehicles, and as you can see from the picture, there are similar standards for rail transport and for medical devices. There are some key components which are needed to implement ISO 26262. So the system which helps us to implement this standard shall provide automotive safety lifecycle, which covers all phases from initial definition and planning until disassembling of the product. This system shall provide support for tailoring the necessary activities during all life cycle phases. It also shall provide an automotive-specific risk-based approach for determining risk classes, so-called Automotive Safety Integrity Level, ASIL. And this ASIL is calculated for item. We will look at these items later. We use ASILs for specifying the items' necessary safety requirements for achieving an acceptable residual risk. So basically we calculate ASIL, then we decide that we need a safety requirement, and then we implement some task which will reduce risk, and the risk will become acceptable. And also the system shall provide requirements for validation and confirmation measures. So we need to be able to store all of this data in the system, and Polarion can help to achieve this in the best way. If we look at ASIL, which is a key component of the process, then we can find out that it is calculated from quite simple formula. The ASIL is determined by severity, frequency, and controllability. If we enter all of these factors, then we can determine which ASIL is for this particular function. So the ASIL is determined at the beginning of the development process. The intended functions of the system are analyzed with the respect of possible hazards. And ASIL asks, if a failure arises, then what will happen to the driver and associated road users? And when the answer is not good, when there is a very high danger for the driver, then we need to apply special measures to reduce this risk. The ISO26262 as a process consists of different parts, or the process can be divided in different steps. The beginning is management of functional safety, and we go to the concept phase, which is on the left. In the concept phase, we need to define some items, we need to define some data, initial data, and then we can move to the product development at the system level. From the system level, we might split into hardware development and into the software development, which is number 5 and number 6 on the picture. After the product is developed, it will go to the production and operation, and there are some supporting processes and safety-oriented analysis. So this is a theoretical approach to the ISO 26262, and some parts of this we will see inside a live demo. When we perform hazard analysis and risk assessment, the concept phase, which I mentioned before, splits into a number of steps. So we need first to define the items. Then we initiate the safety life cycle, and we perform hazard analysis and risk assessment. After that, we will do the functional safety concept. And the hazard analysis and risk assessment splits into some additional steps: hazard identification, classification, determination, safety goal determination. So a little bit more theory, and after that you will start to see more user-friendly pages. What is the automotive safety integrity level, which is the key for determining the level of risk? The ASIL is calculated as a sum of probability of exposure, controllability of event, and severity of a failure. And as a result, we get 5 possible values QM, A, B, C, D, when QM is acceptable level of acyl, and D is the highest level of acyl, which means it brings very dangerous situations. So quite often these levels are displayed visually as a table, and you can see that D is a very red color and QM is a green color, which is acceptable level. So if we go one slide back, the probability is defined as a score from E0, which is unlikely, to E4, which is high probable. For example, how often explodes an airbag while an infant is sitting in the front seat? It's not often. The controllability is another score from C0 until C3. It tells you how controllable is the event. So on one side, it's controllable in general, and on another side, it's difficult to control and manage. Is the infant or the driver able to control the explosion of the airbag? The answer is no, it's not controllable. And the severity of failure, it is another score from S0 until S3. It's the result of the event. So the lowest or not dangerous is no injuries, and the highest is life-threatening event. So how severe will the infant injured? Actually, if the airbag explodes, then it can be life-threatening situation. So it can be up to S3. And once we calculate these numbers, we can define acyl, and actually Polarian can define acyl automatically for you if you provide the right numbers. We will see it soon in the demo. So as I showed already before, if the acyl can be grouped into the table, and in the example of the airbag, low probability of event E2 plus difficult to control controllability C3, and the result will be life-threatening for the infant S3, and we get B as a acyl value. So if we start to move towards managing these data inside some kind of system, then we are looking at this kind of data structure. We have a hazard, we have a safety goal, and we have a functional safety requirement. So the functional safety requirement will try to achieve to achieve the safety goal, and the safety goal is assigned to the hazard. And the hazard has acyl level. So now let's look at Polarian. We finished with the theoretical part and how Polarian can help to manage this kind of data. So first of all, Polarian is a full ILM system. It provides multiple functions which are important to go through the project, define the requirements, manage the development process, and then manage the change process after the product is released to the market. You can see on the left side this nice flower of all the functions which Polarian provides. I will not go through all of them. And on the right side, you can see the areas which are part of the template 26262 inside Polarian. We can look at that requirement specification on the right side is part of the left side functionality of Polarian. You can also do release planning, development, testing, quality assurance. Of course, hazard analysis and risk assessment is also inside this template, but you can move some of the additional functions from the left side into your template, which means you can use agile approach, you can do issue and risk management, you can reuse your data, create branch, and so on. So this is just to give you overview of multiple functions available in Polarian and the template which we are going to investigate right now. So inside Polarian, the data is organized as documents and objects. Object is called work item. Polarian also provides a process, and there is a configuration which allows you to define user access, workflow, and how the information is displayed to the end user. Every change, anytime when you click Save button, it is tracked automatically and saved inside the history, because Polarian underneath has SVN as a file storage, and SVN will create a new revision for every save operation. And this also gives you possibility to revert your changes, and you can restore some data if it is deleted by user. The information is organized inside documents, and also the information can be organized without documents as a simple list of work items. If we look at this example of a change management, then we have three documents, which is from the left to the right: system requirement specification, software design specification, and software test specification. So we have some test cases on the right side, some design in the middle, and requirements on the left side. In Polarian, these data can be linked. We can have connection between specific items, and this will allow us to create traceability. We can find out the impact of any change, and we find the related items and can do the analysis of related information. In this example, if a business analyst will say, I have to change an existing requirement, then we can quickly answer what will be the impact of this change. We can also look at Polarian as a storage for multiple work items, and between them we can define links, and also we can import and export data from the different systems. For example, you can perform simulation in one system and get the result back into Polarian. You can export some test cases, execute them outside of Polarian, and then import the data back. You can connect to the Git repository for the source code or to the SVN, and you can also manage your diagrams for the system level design in Enterprise Architect, and also move data back and forward. So it's a quite open system, and inside it allows to do the connection between the items. Another example, test management. Usually we operate with a so-called V model. In this case, we have some requirements on the left side and some test cases on the right side. Between them, we have traceability, and this V model can help us to see the relationship between the data, and also coverage. Another example, when we store data inside different documents, test cases, and requirements, again, we have links between them. So quite often the problem of the development is that teams are working in isolated areas or isolated tools, and you use Word, Excel, some other tools to manage test results, then you don't have connection between the data. With Polarian, we can unify all the teams, and the data will be stored in the same system. This will allow different stakeholders or participants of the project collaborate inside the same environment. So it can be team leader, business analyst, customers, project managers, developers, and test engineers. They all will see the same data. So Polarian provides multiple functions. for requirements management, for quality assurance, change management, project management. You can create variants of your project, and you can use different connectors to move data around. It gives you historical data. It gives you a way to define a process, and you can perform verification of your requirements. And the data input output is open API to transfer data from any system. So now let's look at the template, because we have only 10 minutes left. So this is the data structure which is part of the template. You can see that we have some red items for the hazard analysis. It's called hazard safety goal functional safety requirement. Then we have some blue items for the, let's call it, normal development of software or system development. It's requirement, test case, defect, and task. And we have some business case for the high level requirements. So the template gives you already predefined work items with some additional fields, and also you can create links between the items, and this picture shows you how the items can be linked. There are also some reports which show the data, and they help you to analyze the data. This example of report shows you traceability or relationship between hazard, safety goal, and requirement. So in this case, we have one hazard 179, which does not have any safety goal connected, and this is a problem. So when we see this kind of report, we need to do some corrections to our project and define additional safety goals. The project is implemented as a V model, so you can specify your requirements from the top level to the low level requirements. You can add additional type of requirements, hardware, software requirements, and on the other side you can have different levels of test cases. And you can see in the left corner it is a real V model from Polarian, which is generated automatically, and it shows you how many custom requirements you have, how many related test cases, how many items are tested, and how many items are not tested. You can also make links from requirements to the source code if you use a connection to the Git or to the SVN repository. The template provides you step-by-step instructions how to enter the data. This is example of the page, and in a minute I will switch to the live Polarian. So let's actually have a look at the project. So this is the project inside Polarian. Oops, sorry. You can see that we have a home screen with some starting points. So it gives you some information where to start and where to add the data. On left side, you can see work items, and there are different types of work items already predefined. For example, requirement, hazard, safety goal, and so on. And you have some documents below, and these documents contain requirements, and also they show you some reports. For example, this is FMEE worksheet, which shows you the potential risk items. So now I open work item. It is stored inside a document, and if I open the item separately, then you can see that it is a risk item. It has some fields, and these fields help to define the ASIL level. So let me go back to the top level of the project, and we will start with the hazard analysis. If we want to see a report about hazard ASIL, then we open this page, and it's a list of items which have different acyl. So for acyl A, we have 2 items. For acyl D, we have 1 item. So these items need to be analyzed by engineers, and the acyl level shall be reduced. Then we have a hazard traceability table. So it shows you that this hazard is related to the safety goal, and the safety goal is related to some safety requirement. There is a special table which shows another type of traceability. It is a safety goal to the hazard, and every safety goal shall be linked to the hazard. So if it's not linked, then it is highlighted with a red color. There is also safety goal coverage, which tells you that this item 176 does not have any functional safety requirement. The data is organized as a document. So this is live doc. You can see some work items inside live doc. And unfortunately, if you do not know Polarion at all, then maybe some concepts are new for you, but we can have another demonstration later about Polarion only. So the work item can be embedded inside a document, and document is a container. We have some special pages. Sorry, just a moment. Let me have a look. We have some pages which help you to define requirements. In this case, you can import existing document with your requirements, and then they will be organized inside special documents. And after that, you need to create links between the work items. And after that, you can perform the hazard traceability analysis or some other functional safety analysis. There is also testing included in this project. In this case, we can see that we have some requirements, and they don't have some test cases linked, and some requirements have test cases linked. So this will help you to verify your V model to make sure that your requirements are tested properly. And there are quite a few help pages which show you how to navigate through the project, how to enter the data, and how to use reports to analyze your safety. So the small summary is that when you use Polarion template for ISO26262, you get well-defined pre-configured work items, and you get a process which is also pre-configured, and you get reports. All of this data can be changed. You can take other projects, and you can migrate some of other processes to expand your project. So the Polarion is flexible for customization and adaptation. There is a traceability because Polarion is based on links between items, so it is part of a product. There is a process control. You can say that the process cannot be changed, and you can control the rights who can change the process, and make sure that your project stays in the right direction through the years of development. There is a very detailed security control, so you can allow your customers to see the data, but you can forbid them to see another type of data. So you can say they can see specific document, they can see specific report, or they can also export data into Excel file, process the data, and then you will import the data back. There is e-signature, electronic signature. if you want to sign a document or sign a work item, there is embedded risk management and quality assurance. There is a test management and change management as well. So you can create a change request, see the impact of your change request to the other requirements, change the requirements, and create a new baseline. So I think now we finished the 30 minutes. This picture shows you that you can combine different projects into your project. You can take ISO26262, add Agile software project, combine with variant management, and this way you define your new corporate standard, and this can grow and cover other departments. So now let's see if you have any questions, and if the demonstration of the live project was not enough, then we can have another session where I can show you in details. So I can see there is one question already in the chart. What about coverage for chapter 5 and 6? Are these included in the template? I think the chapters 5 and 6 are included in template, but I need to check in details. So this is the question from Piyush Karkare. So I will give you the answer a little bit later, but I think it's included. Any more questions? Please write in chat if you have questions. So looks like no questions. We have implemented this template in quite a few automotive companies, and Polarion has became the center of so-called DevOps and requirement specification process. Polarion can easily connect to other systems, and it can help you a lot in development. So if you would like to see Polarion demonstration in details, you can ask me later. There is another question on the software domain. There are new methods like STPA, one moment, which increasingly get integrated with ISO262. How can Polarion support that? Well, about STPA, I need to check. This I don't know yet, but I will answer to you, and also we will send the answer to everyone who participated. There is another question. Yes, the presentation will be available, so you can download it either from our website, or you can also watch the recording of this webinar. Another question is, are all requirements going through ISO26262 in this template? So not all requirements need to go through this ISO process. Usually you define the hazards, you analyze the hazards and the relationship to specific requirements, and then only those requirements will go through the process of analysis. So some part of requirements can stay as, let's call it, normal requirements. Another question is, are there any templates which incorporate SPICE as well as ISO26262? I need to check about SPICE, but we can quite easily merge different templates. It means if there is another template for SPICE, then we can combine them. And to combine template takes maybe two or 3 days. We define what to take from one and another, and then you have a new template. It's more like a copy paste of work items and configurations. Okay, so no more questions, or are there any more questions?